Okay, in this lesson we're going to do some problem solving using the law of cosines. And what problem solving means is you have to figure out what the question is to start with. Instead of being given a triangle and being asked to find one side or one angle, we have to draw the picture, we have to figure out what's being asked. Okay, so here it is. Giles has 3 pieces of wood that he wants to build a frame for his flower garden. The pieces are 10.2, 7.5, 8.4 meters long. Draw and label a diagram showing the triangular frame. Okay, you do not need to worry about doing this to scale. Alright, I'm just going to randomly put these numbers here. If the picture doesn't look right, it doesn't matter. It's a triangle with three sides. That's all you really need to worry about. Okay, so that's your diagram. Now, we could go ahead and label this A, B, C, D. Maybe that helps us. Maybe it makes it easier. So, again, I don't care where the ABCs go, but let's try it there. Okay? So, what will the measures of the angles of the corners be? So, we're supposed to find the 3 measures of the angles. Alright. What angle do you want to find first? It doesn't matter. How about we do B first? I don't know why B. Maybe it's because it's the first one when I read left to right. Okay, so I'm going to go cos B. And by the way, it's not right or wrong if you would have chosen something else. Okay, so cos B, remember that the angle formula, if this is B, that's the side across from it. This is going to be the side that I'm subtracting. That means the other 2 are the ones that I'm adding. And then I'm going 2 times 8.4 times 10.2. Okay? So, let's see if we can figure that one out. So I'd like you to put the top into the calculator and put the bottom in the calculator and see if you can solve. Okay, I'm going to leave that one just for a second because then we're going to have to go and find another angle. Okay, we'll have to find another angle, so maybe let's find cos of A. Okay, so I'm going to get you to set that one up and see if you can find it as well. Okay, I'll give you a couple minutes to try that. Okay, so here are the answers I have so far. Check yours, see if it makes sense. Okay, I found angle B and angle A. You could have found C. In fact, we do have to find C now. How am I going to get C? Well, I'm going to go 180 degrees, take away the 2 angles that I have. Okay, and I think this will give me 54 degrees. So that would be the 3rd angle. Alright, so try that one. Make sure that you're clear on that. Let's try another word problem. Okay, similar question. It gives us some information. The nice thing is this one gives us a diagram. So Grant's a beach lifeguard. He must set up the buoys for a swimming competition. Swimmers will jump off the pier, swim around one buoy, change direction, and swim around a second buoy. Then head back to the pier. The first buoy is 300 meters from the pier, and the second is 200 meters from the pier. The angle between them is 60 degrees. How long is the swim route? So basically, we need to know how far it is around here. We already have 2 sides. Whoops. We already have 2 sides, this one and this one. So what we're missing is this. Okay, we were missing this one. Let's call it x. Okay. So this time we're finding a side. So if you remember the formula, I'm going to write x squared. And then I write the other 2 sides, 200 squared plus 300 squared, minus 2 times 200 times 300 times cos of the angle opposite the side, like this. Okay, so x squared is, so we want to put that all in the calculator all at once. Okay, and it turns out to be 70,000. So x is 265 meters. Now we're not done. So what is the distance of the swim route? Swim route is 265 plus 200 plus 300 equals 765 meters long. Okay. All right. You guys try this one. Pause the video. See if you can get it done. All right, this question is exactly like the previous one. We're finding a missing side, and it's across from the given angle again, so it's a cosine law question. All right, see if that's what you get. Moving on to the next one. Again, I'd like you to try it first. I don't want me to be the first one to do it. Let's quickly look at it though. The radio tower is stabilized by two guy wires. So the guy wires run from the tower and down to the ground like this. Two wires are attached at the same point on the one side of the tower and are affixed to the ground 4.6 meters apart. The first wire is 9.2 and the second is 6.8 meters long. Okay, at what angle of elevation is wire 1 installed? So we're looking for this angle here. Okay, now there's no letters here, and if it would make you feel better, we could go A, B, C, and what we're trying to find is angle A. Okay, and if you remember that formula, cos A is B squared plus C squared minus A squared over 2BC. So we're going to get, what are the two sides? Well, we have all three of them. What side is opposite angle A? That's this side. So then we're going to use the other two. 9.2 squared plus 4.6 squared. And then we'll subtract the side that's opposite. 6.8 squared. Over 2 times 9.2 times 4.6. Okay, that's cos of A. So cos of A will be 59.56 over 84.64. And so the angle that we figure out is 45 degrees. That's the first question. Then it says how high up are the tower are the wires attached? Well, this is a little bit trickier. We're supposed to find this distance. Okay? So that's not part of our red triangle. So let's make a new triangle. Let's take this triangle and draw it. Now, if we took a close-up view of that triangle, this one turns out to be a right triangle. Okay, we have 9.2, and we now have this angle. It's 45 degrees. Okay, so this one is actually a trig question. We are going to use sine, cos, or tan. Which one are we going to use? Well, this is the opposite side, this is the hypotenuse, and this is the adjacent. We're going to use opposite over hypotenuse, which is sine law. Or sorry, not sine law. So you get sine of 45 is x over 9.2. And if you do your cross multiplying, you end up with x is 6.5 meters. Okay, so this is quite the word problem. We got all kinds of different things going on here. How far from the base of the tower is wire 1 attached? Okay, so now we're looking for this distance. All right, we'll go back to that triangle we just drew, because that triangle has this distance. Let's call this one y. Okay, and we now know this is 45. We still know this is 9.2, and we just figured this out to be 6.5. Okay, now you could say, hey, well, maybe I made a mistake here. Let's not use that side. So instead, let's use cosine, right? Because this is the adjacent and this is the hypotenuse. Okay. So cosine of 45 is y over 9.2, and y is 6.5 meters. All right? Okay, so we are at the end of this unit. Now it's time to do some reviewing. All right? let me just quickly go through a few things. So the first, when you're doing these triangles, if it's a 90-degree angle, then you can use sine, cos, tan, and you can also use Pythagoras. Okay? If it's an oblique triangle, though, which most of them will be in this unit, you're going to ask yourself, do I use sine law or do I use cos law? And how do you know which one to use? Well, that's the trick. That's the key to what you need to learn. Okay, remember that with sine law, you have to have an angle and its opposite side. You have to have both pieces. With cosine law, you don't. Okay, so please do the test review, and let's get ready for our test.